Policy management in Kubernetes is a huge, no, massive deal. It's probably one of the first things you want to do, you want to apply after you set up the initial cluster. Since the emergence of Kubernetes admission controllers, we got tools that leverage them to validate and enforce policy. We can use Kyverno, OPA Gatekeeper, Datree, and others to define and enforce policies. If you're using Kubernetes, you're likely already using one of those tools. If you're not, well, you should start by watching those videos. But what if I tell you that those tools are in trouble? What if I tell you that they are to be extinct or be forced to adapt to a new standard? Today, we are going to explore Kubernetes Validating Admission Policy, which was introduced as an alpha feature in Kubernetes 1.26. But before we dive into it, let's see how admission controllers work. Validating that will help us understand how validating admission policy, remember, something that is now part of Kubernetes, it will help us understand how that works. However, to understand how admission controllers work, we need to understand how Kubernetes API works. So let's start with a quick overview of the Kubernetes API. What happens when we send a request to Kube API? Let's say, for example, that we send a request to apply a deployment resource. A user, which is me or you or some process maybe, sends an HTTP request with the YAML that defines a resource. And in this case, that resource is a deployment. That request is forwarded to the authorization and authentication layers that confirm that you or some process are allowed to create or update or edit or delete that resource. And now comes the interesting part. The request is forwarded to the admission controllers, right? Now, there are many admission controllers built in, and I do not care about any of those today. What I do care is that at some point, the request is forwarded to the mutating admission. Now, what does it do? Well, it does not do much by itself. Instead, it sends webhook requests to controllers that might, and I repeat, might change the definition of the resource. Now, what are those controllers? Well, that depends on you. There are no mutating webhooks built in, at least not at the time of this recording. We can write our own, only a few of us do that, or we might have them through third-party tools. For example, we might have a service mesh that is configured to automatically add sidecars to every pod. In those cases, that service mesh, if done right, would register a mutating webhook. Or we might use a tool like Kyverno to define ourselves mutations. We could check, for example, whether memory and CPU limits are defined, and if they're not, we can add them to, in this case, deployment resource definition. Personally, I think that mutations are dangerous, and they can often cause more harm than good, because they start changing things at runtime, and we already know that we should be defining things in Git, storing the definitions in Git, use GitOps and all those things. So I believe that they're dangerous. Nevertheless, they're a thing, and you might choose to use them, or you might have third-party tools that use them with, or sometimes without, your consent. In any case, mutating admission controllers can modify the manifest of the resource passed to the Kube API. Now, once mutations are finished, the final version of the resource is sent to object schema validation. That's the process that confirms that the resource is valid, that it complies with resource definition or custom resource definitions defined in a cluster. If it does, if it's valid, the request is forwarded to validating admission controller. And that's where the real magic happens. Validating admissions work in a very similar way as mutating admissions. They send webhook requests to controllers that might validate the resource. That's the one we're interested in today. Those webhooks either say, yeah, it's okay to create or update or edit or delete the resources, or they might say that it is not. That's the job of validating admission controllers. We could, for example, have a rule that would deny the creation of a deployment resource if it does not have a memory limit defined. If that limit is below or above certain thresholds, or if the number of replicas is higher than, let's say, 3, so on and so forth. Validating webhooks allow us to define rules that must be followed to enforce good practices, to ensure the stability of the system, to make it secure, and so on and so forth. Validating webhooks are one of the most important features Kubernetes has to offer, and they are indispensable for any, and I repeat, any serious organization, especially when running at scale. That's where tools like Kyverno and OPA Gatekeeper and Datree shine. And those are the same tools that might now be in trouble. But we'll get to that in a minute. For now, let's get back to events, since there is only one left. After a request with the final version of the resource is validated, it is persisted in etcd. Think of etcd as a database. It's a distributed database that stores the state of the cluster. Once a resource is stored in etcd, one or more controllers might do something with it. The deployment controller might create a replica set, and it would do that following the same process. Send a request, mutate, validate schema, validate, persist, and so on and so forth. A replica set controller might create pods, and again, the same process would be repeated until there is nothing to do, or until it reaches the scheduler that will run physical processes in pods, or in VMs, or as WASM, or whatever else we might have configured. All in all, the resources are finally created in the cluster. Now, let's get back to the trouble part of this video. I said that the tools that we use to define and enforce policies might be in trouble. Kyverno, OPA Gatekeeper, and Datree are all built on top of the validating admission controllers, or at least parts of them are built on top of it. That's great, except that all of those have their own formats to define policies, and we just received a standard that might replace all of those formats. Since Kubernetes 1.26, we have Validating Admission Policy. Let's see what it is, how it works, and how we can use it. Now, let's take a look at a simple example of Kubernetes Validating Admission Policy that was just introduced. Unless you're watching this in the future and then it was introduced a while ago. Anyways, here's an example. I'm doing two things here. First, unrelated, at least not directly related with validation policies, is that I'm creating a namespace. And there is nothing special about this namespace except that it has a label environment production. Remember that. That label will become important later. Then we have validating admission policy definition. That's the one that was just introduced into Kubernetes as alpha. We'll get to that later as well. So the name is max replicas. You can guess from the name what it does. We're defining failure policy to fail. It could be a warning or information or something like that. It could be not fail, but I want my policies to fail any attempts to apply something that shouldn't exist. We have match constraints that say, hey, I want to define this admission policy for all resources that follow certain rules, and those rules is that resources in API groups, apps with versions v1 should apply certain policies if operations are to create or update that resource. So no policies for deleting, but policies for creating and updating, and the resources in question are deployments and stateful sets. And then we have validations. This is where the calculations are happening. There is an expression that says, hey, if object spec replicas, the path to the replicas field, is smaller or equals 5, then you should fail. And the message is replicas must be less than or equal to 5. So in other words, This policy will allow manifests to be created as long as they do not have more than 5 replicas specified. Now, in this case, I'm ignoring the fact that I would never specify replicas inside of a deployment of stateful sets. I would use horizontal pod autoscaler, or probably KEDA, to automatically scale my application, and either of those two would manage the number of replicas. But anyways, I'm ignoring now that complexity and going straight for the number of replicas in a deployment or a stateful set. If you're interested in KEDA, and you should, there's a video for that as well. Check it out. Now, that definition was a policy in itself. Nothing is happening just by having a policy in a cluster. We need to specify, we need to bind that policy to something. And in this case, we're going to bind it to that namespace that I defined at the top. So we have the third specification that says, hey, I want validating admission policy binding. We have a name, we have the name of the policy that it should bind to something, and what that something is defined in match resources that says, hey, I want to have a namespace selector, and I want that selector to match any labels that are environment production. So any namespace that have the label environment set to production is going to use this policy. In other words, if I try to create a deployment in any other namespace, a namespace that doesn't have that label, nothing will happen, assuming that there is only this single policy. Now, let me go back to that expression in the policy itself, because it might be worthwhile explaining how we define those expressions. In this case, it is using CEL, or Common Expression Language, which is a separate language, very simple, very easy, intentionally very small and simple and easy to use without many bangs and whistles. So check it out. I will provide the link in the description if you want to know more. Now, let me apply those definitions first, and then we'll see whether it all works. So I'm going to execute kubectl apply whatever is defined in the file vac/deployment YAML, and we got our namespace, and we got the admission policy, and we got the policy binding that binds it to all the namespaces with specific labels. By the way, it doesn't have to be bound to a namespace, but that's still work in progress, so check out the documentation. Now, let me deploy an application as well, one that, among other things, contains a deployment, and I will do that with kubectl namespaces production. I want to apply whatever is defined in customized base, and I got service deployment ingress. Everything worked, nobody complained about anything, because this application probably, I hope so, falls within the constraints of that policy, so policy did not complain so far. And we can confirm that by listing all the pods in the namespace production, and you can see that there is one pod. So it's normal that nobody complained, because the policy says, hey, you can have anything between 0 and 5 pods. If you try to put more than 5, then you're in trouble. So let me put myself in trouble. Right? I'm going to show you a file defining customized overlays replicas deployment YAML. This is a customized overlay that will overwrite a specific field of a deployment. Specifically, it will change the spec replicas to be 7. So I'm going to try to change the number of replicas to 7. This 7. There you go. So, standard stuff, kubectl namespace production, I want to apply whatever is defined in that specific directory of customize, which will try to change the number of replicas to 7, and we can see that nothing happened with the service, because it's the same, nothing happened with the ingress, but when it comes to deployment, the validation policy kicked in and says, hey, it is invalid. Validating admission policy called max replica that is bound to max replica binding denied this request. Replicas must be less than or equal to 5. You cannot do it. Now, there is a problem, an issue with admission controllers in general. Doesn't matter whether you're using validating admission policies that I'm using right now, those baked into Kubernetes, or you go with Datree, or you go with Kyverno, or OPA Gatekeeper. As long as they're based on admission controllers, there is an issue, and that issue is that they do not understand the context of the application itself. Each resource is validated separately. Now you might say, hey, what's the problem with that? But if each resource is validated separately without understanding the rest, the context of everything we are trying to push to Git, to Kubernetes, not Git, then we cannot have more complex policies. We cannot have a policy that validates, for example, whether the number of replicas is set inside the deployment or, let's say, inside the horizontal pod autoscaler. So this policy would not complain at all if I did not set number of replicas and then horizontal pod autoscaler scales it to 100, right? It wouldn't complain, or to be more precise, it would complain, but not to me, but to HPA, and then HPA wouldn't be working and I wouldn't know why it's not working. It would be a whole mess. Eventually it would work, but I would not know that there is an issue in my manifests. Now, let me try another validation policy. This time I want to see whether it works with anything, because as time passes, we have more and more custom resources in our clusters. So I need to be able to define policies not only against things that are baked into Kubernetes, but against custom resource definitions. That could be Argo CD or Flux or PostgreSDB deployed with an operator. But in this case, since I'm fond of crossplane, I will use it as an example of double checking whether validations work against any Kubernetes resource, including custom resources. So let's take a look at Customized Overlays DB, very big database, Postgres, YAML, and over there we have a secret, ignore that, and we have SQL claim. So SQL claim is mine, doesn't exist in Kubernetes. I defined it through crossplane compositions, and I want to see whether I can use it and whether I can validate it. So if you're not familiar with crossplane, check out those videos and you'll find more details. I will not go into details except to say that this is custom resource. So check out those videos and you'll find out about crossplane. I hope that you already know what it is. Anyways, let's go back to the subject and what should I do now? Oh yeah, I should define a policy against that resource that will prevent me from doing silly things. So I already have it. It's defined in VAC crossplane YAML, and there is validating admission policy. Just as before, the constraints are saying, hey, this time I want you to validate something in the API group called DevOps Toolkit series.com, and that API version is v1 alpha 1, and I want to check for operations, create and update. And this is now important. Resources that you should validate are called either SQL claims or SQLs. And the expression is slightly more complicated now, right? It says, hey, I want you to validate an object, and inside of that object you will find spec parameter size, and that value of the size should match following values. The values of the size can be either small or medium or large. And you can deduce that from the message as well. Size must be one of small, medium or large. If somebody tries to put any other value in that field, it should fail. Now, if you remember the manifest from before, I did not use either of those three values, so it should fail, but we'll get back to that. And then we have the binding of that policy that is slightly different. In this case, I'm still selecting the namespace, but the expression says, hey, the key should be environment. That's fine. And the operator should be not in. And the values is silly. What that means is that the policy will be applied to any namespace except a namespace that has the environment label set to silly. And then we have another policy for the same resources and the validations. There are two validations now. First of all, spec parameter size this time must be medium or large. So it cannot be like previously it was for all namespaces except those that are labeled as silly. It can be small, medium and large. And this time I'm saying, no. I want only medium and large. Even small is out. And the version must be, and this is now regular expression, right? Something you should know. It says 1, and then the second digit is between 3 and 4, and then dot and anything after that. Meaning any version that is 13 dot anything or 14 dot anything. So any subversions of 13 and 14 are allowed. Anything else? Nope, nope. And the policy binding for that one says, hey, this applies. The previous one applied to anything except namespaces that have environment set to silly, but this one is not excluding, but including and saying, hey, this one applies only to the namespaces that have the environment set to production. So let me apply those policies. First, in the bindings with kubectl apply, file name is vac crossplane YAML, and now we can do some tests. Let's say that we are going to try it first in the default namespace, right? Default namespace does not match any of the criteria for the second policy, so it should match only the first policy, right? The one that says, hey, small, medium, or large are the only allowed values in any namespace that is not marked as silly. So I'm going to execute kubectl, namespace is default, I want to apply whatever is defined in customized overlays DB, very big database, and we can see that everything was created except the SQL claim. It says it's not valid. It must be small, medium, or large. And if I remember correctly, what we tried to apply was the size very big or something like that. So I could not apply that manifest because it is not correct. It is not valid and it is not allowed. And I know that because policies are preventing me from doing silly things. So let's take a look at a different specification. This time one defined in customized overlays DB small Postgres YAML. And this one is almost the same as the first SQL claim manifest, except that the size is this time set to small. This should work. I should be able to apply this because it matches small, medium, large as allowed values, right? Now, if I apply inside of the default namespace, whatever is defined in the directory dbSmall, the one I just showed you, that worked. It worked. That's it. Policies did not complain because there is no policy that prevents me from deploying small database into the default namespace. Now, let me delete that one because I want to try something somewhere else. And then I'm going to try to apply exactly the same, but in the production namespace. And now the policy says, no, I couldn't apply the same manifest, but in a different namespace, because the different namespace has the label that says environment is production. And for that one, we have the second policy applying that says only medium and small are allowed. Oh, that's a mistake of the message. It should be medium or big, not medium and small. Anyways, it's not allowed, even though I made a mistake in the message. Now, let's go through the last, I believe, manifest for today. Again, something defined in overlays DB Postgres YAML, and this is almost the same manifest, but the size is set to medium. Previously, it was set to small, I believe. And let's see whether this works, whether this manifest is valid according to policies. So if I execute kubectl namespace production apply, that slightly modified manifest, it works because medium size in that context is allowed. The few policies I have applied are allowing me not only to be safer, not only to do the right thing, but also to learn what I should and what I shouldn't do according to the overall rule set for my organization. I believe that's enough of a demo. Let's talk about pros and cons of using Kubernetes Validating Admission Policy that is baked in Kubernetes starting from 1.26. Let's start with pros and cons, and after that discuss the future of other tools like Kyverno, OPA Gatekeeper, and Datree, probably others as well. And I'm going to start with negative things, the things I don't like about what we got inside Kubernetes now. To begin with, it's alpha, at least today, which is March 2023, meaning that the API might easily change, the docs are almost non-existent, there aren't many examples, and so on and so forth. That's normal for alpha features, and that will change as the API is moving towards beta and V1 later on. Remember, in Kubernetes world, beta means stable. You can start using beta, or if you want to be 100% certain that it's working because everybody else is using it, then V1. Or if you want to be 100% sure, then you wait for V1. But V1 means that everybody else is using it. So start using, in generally speaking, something when it becomes beta, but not alpha. And the second problem is that there is still a problem with the context. It's silly to ignore the fact that everything in Kubernetes is a collection of resources and that we should take them all into the account, like replicas in the deployment or HPA. You need to know whether there is HPA or no, to know what to validate and so on and so forth. So admission controllers are kind of failing in general. Doesn't matter whether we use the ones baked into Kubernetes or to third-party tools. They're flawed in the sense that they do not understand the context of what we're trying to do. So that's the problem of admission controllers and Kubernetes API in general, rather than the validating admission policy. Now let's go into pros. To begin with, what you're seeing right now is the de facto standard. It will be the de facto standard for validating Kubernetes resources, just as, let's say, ingress and soon gateway API is the standard for routing external traffic. That does not mean that you shouldn't use third-party tools, but once Kubernetes community defines standard API for something, you should be using that API. And by the way, if you're not familiar with Gateway API, check it out. There is a video for that as well. Second, I really like that the community chose cell as the language for expression. It's a good one, even though it's not very well known one. It's simple by design and it is easy to learn, yet it provides more flexibility and power than just pure YAML or things that other tools tend to be using, like Kyverno or Datree. OPA Gatekeeper is out of this world. It is much more powerful than cell, but also much more complicated. So cell is like somewhere in the middle, not pure YAML, not complicated regular rules. It's just right. Now, here's the thing. I expect all Kubernetes policy tools to start moving towards this API and bring specific features on top of it rather than creating their own APIs. They already have their own APIs, they already have their own standards, but now we have the standard, and I expect all other tools to move towards adopting it and then building additional features so that they can be competitive. That should apply to Kyverno and to Datree and quite a few others, especially those based on YAML. So OPA, no. That will never move into this format, but others should. Otherwise, if those tools do not adopt this API as the standard API, those tools might be facing a similar situation as observability tools that do not implement OpenTelemetry API, especially since validating admission policy will be baked into Kubernetes once it reaches the beta status. Right now it's in alpha, so we need to install it separately, but once it becomes beta, it will be available in every single Kubernetes cluster. So other tools will have to adopt it or face potential consequences. Now, I know that the tools like Kyverno and Datree are much more feature-rich than validating admission policy. So I'm not saying that they should abandon those additional features, but that they should adopt the validating admission policy and work on top of it. So here comes the most important question. Should you use validating admission policy? The answer is not today. Start playing with it and see how it works for you. Prepare yourself for adopting it once it reaches the beta status, and when that happens, go full throttle with it, directly or through a tool that implements it, tool that builds on top of it. I hope that Kyverno and Datree will be one of those tools, and I know that new ones are already being developed. So competition is coming. We will likely have a situation similar to the one with the Gateway API, where the API is the same, but the tools that implement it differ. If that does not happen, if the existing tools do not adopt the new API, I predict that they will be in trouble and I will not recommend them. But that is the future. Today, right now, I do recommend using Kyverno or OPA Gatekeeper or Datree, but also to keep an eye on Kubernetes Validating Admission Policy. It will likely become a standard and it will likely be an important factor when choosing tools to manage validation policies. Thank you so much for watching. See you next time. Cheers.